Hi students, welcome to Max Point of View. Today we are going to solve each and every numerical which is there in the textbook from the chapter Work Energy Power Part B, that is nothing but 2B numericals. Okay, before starting the numericals, I suggest you to watch the concept video, then we have solved each and every theory question which is there in your textbook. So if you have that knowledge, then 80% of the numericals you can solve aram se without any help. So you watch those videos will be available in the description box. Watch it, then aram se you can solve all the numericals. Now we'll solve our first numerical. Two bodies of equal masses are placed at heights h and 2h. Find the ratio of their gravitational potential energy. This question we have solved during the concept video. Again we are going to do it, and it's a very simple question. Okay, it's a first question. Okay, first I'll write the diagram. Through the diagram we'll understand the concept. Assume there is a object, we can assume it as ball. Okay, assume there is a ball. Okay, this is B1 and this is B2. Okay, B2 is an object. Okay, this is a ball and they have same masses, equal masses, and the height from the earth surface, this is h, and this will be 2 times this height. Okay, now we have to calculate the ratio between the gravitational potential energy. First we will apply gravitational potential energy formula to this one, then we'll apply to this one, then we'll find the ratios easily. Okay, first, okay, this one gravitational potential energy, right? 1, gravitational potential energy 1. So the here in both the cases mass remains same, and we are talking about the same place, so gravity also remains same. The only different quantity will be height. Okay, here this is the formula, correct? mgh is the formula. Here we are taking this as h. Then gravitational potential energy 2. For this one again mass is same, gravity is same. Here instead of using h we are using 2h. So now we have to find the ratio. What do you mean by ratio? So we are going to divide the first quantity with the second one. Okay, then whatever the simplified answer we have, that will be the ratio. I'll show you how to get it. Okay, that is nothing but GPE1 divided by GPE2, that is nothing but mgh divided by mg2h, correct? Now cancel the physical quantities. Mass and mass get cancels, gravity get cancels, h and h get cancels. Here after cancelling everything we have remained with 1, here we have remained with 2. Okay, therefore the ratios, okay, the required ratio is 1:2. Okay, see, I have written whatever is there in the numerator first, then the denominator. This is how we will calculate the ratios. Second question, find the gravitational potential energy of 1 kg mass kept at a height 5 meters above the ground. If g is equal to 10 meter per second square, we have to find the gravitational potential energy. So when it comes to numericals, we have to write the given data. Then only it will be easy for us to solve all the numericals. Okay, this is the second one. What are the given data? Mass is equal to 1 kg, then height is equal to 5 meter, g is equal to 10. Don't worry about, when it comes to gravity, don't worry about the units, you just worry about the value. But apart from this one, whatever is there, you have to make sure that everything is in SI unit. What is the SI unit of mass? Kg. So this is correct. What is the SI unit of height? Height is nothing but length. What is the SI unit of length? Meter. That is in meter. If it is in centimeter, you have to convert into meter. If this is in grams, okay, you have to convert into kg. Final thing is mass should be in kg, height should be in meter. Don't worry about the gravity. Gravity will always be correct. Now, what is the formula? gravitational potential energy. See, in the exam, try to write the expanded form. Okay, that is nothing but mgh. What is the value of m? 1. Okay, don't worry about the units, just write the values because everything is in SI unit. Then gravity value will be 10, that is given in the question. Then height value will be 5. 1 into 10 into 5, that is 50. What is the quantity we are talking about? Potential energy. So the unit will be joules. That's it. Question number 3. A box of weight 150 kg has gravitational potential energy stored in it equal to 14700 joules. Find the height of the box above the ground. Very easiest question. First we will write the given data, then we will get the answer easily. Okay. So gravitational potential energy, you can take it as U also. U is nothing but potential energy. Gravitational potential energy is a form of potential energy. We can use U also, no issues. So the value will be 14700 joules. Then kgf is given. Mass, what is the unit of mass? Kg. What is the unit of weight? Kgf. 1 kg is equal to 1 kgf. So here they have given 150 kgf. 150 kgf, that is nothing but 150 kg only, no need to convert into anything. Then gravity value is not mentioned in the question, so we can assume it as 9.8 or 10, anything is fine. For this question we will assume it as 9.8. you can take it as 10 also, no need to worry about the unit. Then we have to find the H value. What is the formula for gravitational potential energy or just potential energy? mgh, correct. What we have to find? H, right? So H is equal to U by mg, correct. So we need to find H. Apart from H, we will move everything to this side. So this is nothing but H is equal to U by mg. What is the value of U? U is nothing but 14700. What is the value of m? That is 150. G value we have assumed it as 9.8. you can take it as 10 also, no issues. 9.8. when you multiply 150 into 9.8, we will get 14700. here 14700. Now this one's and this is 10. We are finding H, right? What is the unit of H? Height, that is meter. That's it. So this is how we calculate the answer. Question number 4. A body of mass 5 kg falls from a height of 10 meter to 4 meter. Calculate the first one, the loss in potential energy of the body. Second sub question, the total energy possessed by a body at any instant. Take G as 10 meter per second. First we will write the values. Okay. Here mass is given as 5 kg. 5 kg or 5 kg of both are same. Then height, h1 is equal to 10 meter, h2 is equal to 4 meter. See, initially it was at h1, that is why I have taken h1 as 10 meter. Now from 10 meter it has fallen down to 4 meter, that is why I have taken it as h2. Now what are the remaining things given? G is equal to 10, don't worry about the units. Now first one we have to calculate the loss in potential energy. Loss in potential energy or U. Okay. Now first we have to calculate loss in potential energy. What do you mean by loss in potential energy? See, here at the 10 meter, first we will write the diagram, then we will understand. Assume the ball here, assume an object or a ball is somewhere here. The height is 10 meter. Now from here it has fallen down to here, somewhere here. Okay, that is 4 meter. Okay, now here potential energy is directly proportional to height. More the height, more will be the potential energy. From 10 meter it has fallen down to 4 meter. Now there will be a loss in potential energy, right? That is what we have to calculate. Okay, very simple. First we are going to calculate potential energy for this height, then we are going to calculate potential energy for this height, then we will subtract it, we will get the answer, correct? So how many calculations we have done? one potential energy, second potential energy, then finding a difference. So how many calculations? 3 calculations we are doing. That is a longest method. We can apply the simplified formula which is given in the textbook. Okay, what is that? U is equal to, okay, mg remains same, correct? Mass, we are talking about the same ball, so for both the cases h1 and h2, mass remains same and gravity also remains same. So in which case we have the maximum value 10 meter, right? So we will apply that first, minus h2. Okay, here why we have to subtract it, why we cannot add it? Here we are talking about loss, correct? So at this side we have maximum potential energy for this condition, and for this side we have minimum. So loss in potential energy will be subtraction of both the cases, correct? That is why we are using subtraction. Then mass is given as 5 kg, gravity is 10. What is h1? That is 10. What is h2? That is 4. This will be 5 into 10 into 6. 5 6 are 30. 30 into 10, that is 300. What we are calculating? Potential energy. What is the unit of that? Joules. So this is the answer. Instead of calculating this first, then potential energy for this one and subtracting both, will get the same answer. Instead of doing all those circles, we can use simplified formula which is there in the textbook and we will get the answer directly. Now we have to calculate total energy possessed at any instant. So they are not talking about total potential energy or total kinetic energy, total energy. Then definitely they are talking about mechanical energy. What do you mean by mechanical energy? The sum of both potential energy and kinetic energy, correct? So now at any instant, potential energy and kinetic energy, okay, when we add it, we will get the same answer. We will talk about the first instant. That they are talking about any instant, right? We will take this instant only, okay? At this height, okay, potential energy will be maximum and kinetic energy will be 0, correct? Here at this height, potential energy will be maximum and kinetic energy will be 0. At this height, what will be the potential energy? We will apply the formula. Total energy is equal to U plus K. What is U? Potential energy. What is K? Kinetic energy. So at this height, okay, at height 10 meter, okay, total energy G will be, what is the formula for potential energy? mgh plus kinetic energy half mv square, correct? So mass, gravity and h value we have it. Now we'll substitute the values. M is nothing but 5 into G 10 into height 10, then plus, if the object is not moving, okay, at this height 10 meter, if the object is not moving, what is the answer for kinetic energy? If the object is not moving, kinetic energy will be 0. So this is 0. 5 into 10 into 10, that is nothing but 500 joules. Okay, you may get one simple question, why we have to take only this instant? Why we cannot take anywhere, somewhere here or exactly at the bottom? You take any point, the total energy will remain same. I'll tell you, okay, I'll give you one example. Listen, as the ball falls down, the potential energy, maximum potential energy will keep on decreasing, correct? Once the potential energy keeps on decreasing, okay, when it is falling down, the speed increases, correct? If the speed is increasing, kinetic energy will keep on increasing. How much potential energy is lost, that much kinetic energy will be gained. So if the potential energy at this point is 250 joules, then kinetic energy will also be 250 joules. Then 250 plus 250, 500 joules. At this point, exactly before reaching the ground, potential energy will be 0, kinetic energy will be 500 joules. So at any point, total energy will remain same. Why? Total energy is nothing but, mechanical energy is nothing but sum of potential energy and kinetic energy. Question number 5. 5. Calculate the height through which a body of mass 0.5 kg is lifted if the energy spent in doing so is 1 joule. Take g is equal to 10 meter per second. First we will write the given data, then we will try to understand the question. Question number 5. So mass is equal to 0.5 kg. Then work done is equal to 1 joule. Then g is equal to 10. Don't worry about the unit, we have to calculate the h value, height, correct. See here in this question, instead of giving potential energy, they have given work done. See, when it comes to potential energy or kinetic energy, if they have given work done, then that is nothing but, if we are talking about potential energy, that is nothing but work done. If we are talking about kinetic energy, work done is again equal to kinetic energy. Okay, now all these things are given, so W is nothing but U only. Now we have to calculate H. U is equal to, potential energy is equal to mgh. We have to calculate H, so we'll move mg that side, H this side, here U divided by mg. Now we'll substitute the values, we'll get the answer directly. U is equal to 1 joule, no need to write the unit. Mass is given as 0.5 into gravity value, we have to take it as 10, that is given in the question. If it is not given, you assume it as 10, you will get full marks, don't worry about it. H, okay, 1 divided by 0.5 into 10 will be 5, so 1 divided by will always be 0.2. So what is the unit of H? Joules, right? No, you should not always write joules when it comes to potential energy or kinetic energy. You need to see what we are finding. We are finding height. Height, what is the unit of height? That is meter. So H is equal to 0.2 meter. Question number 6. A boy weighing 25 kg climbs up from the first floor at a height 3 meter above the ground to the third floor at a height 9 meter above the ground. What will be the increase in his gravitational potential energy? Little confusing but very easy question because we have solved one question like this, correct? So first we will write the given data. See, for this question, if you write the diagram, it will be really helpful. In the exam, if you write the diagram, don't worry, they are not going to cut the marks. That is for your reference, okay? First I'll write the diagram. See, this is the ground, okay. Now the boy is on the first floor, okay. This is the first floor, okay. From the first floor to the ground floor, okay, it has 3 meter height. It has 3 meter height. Now he is going to climb to the third floor, okay, third floor, which is 9 meter height from the ground level. Okay, now we have to find the increase in his gravitational potential energy. Here he has some gravitational potential energy, correct? Why? Because he is not on the ground. If he is on the ground, gravitational potential energy will be 0. Why? Because height, h value will be 0. If some object or some person is standing on the earth surface, then there will be no height, correct? There will be, if I am standing here on the earth surface, what will be the height? The distance between me and the earth, I am standing on the earth, so height or distance will be 0. He is not standing on the earth surface, he is standing in the first floor, so he has some potential energy, correct? Now from the first floor he has moved to third floor, which is of 9 meter height. Now see, as the height increases, potential energy will also increases, correct? We have to calculate what is the increase in potential energy. How we can calculate that? First we will calculate the potential energy for this one and this one. If we subtract, we will get the answer, correct? No, we are not going to use that method because here it includes 3 calculations. Instead of that, we are going to use one simplified formula which is there in the textbook, which we have already used in previous question. So first we will write the given data. What is the mass of a boy? Okay. Now we have to think in a practical way that, okay, if the person, okay, the boy is standing here, and if he goes to the third floor, the mass of the boy remains same, correct? So if he is standing in first floor, ground floor or 9th floor, any floor, the mass remains same. Then height h1 value will be, initially it is 3 meter because he is standing in the first floor, that is 3 meter. h2 value will be 9 meter. Then gravity value they have given it as 10. Don't worry about the units. Now we will calculate increase in potential energy, that is nothing but U. Okay, what is the formula? In both the cases, if he is standing here or there, okay, mass and gravity remain same. The only difference will be height. So which one I have to write first, 9 meter or 3 meter? We have to always write 9 meter. Why? Because 9 is greater than 3. If we take 3 first, we will get the answer as negative. We don't want that. Okay, now h2 minus h1, m value will be 25 into 10, h2 value will be 9, h1 will be 3. So 25 into 10 into 6. So 25 6 are 150 into 10, that will be 1500 joules. That's it. This is the increase in potential energy. First we will calculate this one, then this one. If we find difference, then you also will get the same answer. Instead of doing all the circles, we can use the simplified formula. Question number 7. A vessel containing 50 kg of water is placed at a height 15 meter above the ground, assuming the gravitational potential energy at the ground to be 0. Okay, we have to assume gravitational potential energy on the earth, okay, on the ground to be 0. Why? Because there will be no height, no distance from me. Assume I am standing on the ground, there will be no distance from me to the earth, correct? So h will be 0. If h is 0, gravitational potential energy will also be 0. That is what he is telling us to assume. What will be the gravitational potential energy of the water in the vessel? Take g is equal to 10 meter per second square. First we will write the given data. This is a very simple question. All the values are given, we just have to calculate the value. Okay, mass of the vessel or water, that is 50 kg. Then height is equal to 15 meter. Then g is equal to 10. Don't worry about the unit. What is the formula? Gravitational potential energy or potential energy, U is equal to mgh. What is the value of m? That is 50. G value, that is 10 into 15. Okay, 15 5s are 75. How many zeros are there? 2 zeros. Okay, this is the unit of potential energy, that is nothing but joules. All the time, okay, whenever you are calculating something, you have to know what you are calculating. For everything, just don't write joules or meter. Okay, we have to understand what we are finding. According to that, the SI unit we have to use. Question number 8. A man of mass 50 kg climbs up a ladder of height 10 meters. Calculate the work done by the man. Second one, the increase in his potential energy. G is equal to 9.8 we have to take. Now see, first we need to understand the question properly. Again, if for your reference you can draw the diagram. Now assume a person who is standing on the ground. Okay, now he uses a ladder to climb up 10 meter height. Okay, if he reaches here, somewhere here, okay, the height will be 10 meters. So this is the question. We have to calculate two things. First we will write the given data. Mass of the person will be 50 kg. See, he will be 50 kg while standing on the ground. Once he climb up 10 meter, again he will be 50 kg only. So in both the cases mass remains same. Then G value we have to take it as 9.8. Now he is standing on the ground surface, correct? If he is standing on the ground, what will be the height? Height will be 0. If he is standing on the ground, height will be 0. So h1 will be 0 meter, then h2 will be 10 meter, correct? After climbing from this position to this position, he will reach 10 meter height. Now we have to calculate work done. Okay, work done. What is the work done formula? Work done is equal to force into displacement. What is the formula for force? Force is equal to mass into acceleration due to gravity into S. Here in this case, S is nothing but 10 meter height. So the displacement from 0 meter to 10 meter he has displaced, that is nothing but height only. So m, g, h, we can use it as h also. M is nothing but 50, g is nothing but 9.8 into 10. 490 into 10, that will be 4900 joules. 4900 joules. This is the work done. Now we have to calculate, okay, increase in potential energy. Now see, from this position h is equal to h1 will be 0, here h2 will be 10 meter, correct? Now we have two positions, two conditions or two situations. Now we have to use the simplified formula, that is nothing but u is equal to mg, this height and this height. Which height we have to take first? h2. Why? Because it has the maximum value, just to avoid the negative value. So h2 minus h1. If h1 has maximum value, then we have to use h1 first, then h2. Okay. Now mass of the person is 50, g value is 9.8 into h2 is 10 and h1 is 0 because he is standing on the ground. Then 50 into 9.8 into 10 is nothing but this value. So 4900 joules. That's it. Okay. So if you understand the concepts, if you cannot understand, then try to draw the reference diagram. That will definitely help you. Question number 9. A block A whose weight is 100 Newton is pulled up a slope of length 5 meter by means of a constant force that is equal to 100 Newton as illustrated as mentioned in diagram. First question, what is the work done by the force F in moving the block A 5 meter along the slope? Okay. Second sub question, what is the increase in potential energy of the block A? Third sub question, account for the difference in work done by the force and increase in potential energy of the block. Okay, don't worry about the third question, I will explain it later. First we will find work done and also potential energy. Now first we will write the given data. What is the weight? So here he has given weight as 100 Newton. Okay, if Newton is the unit, then what quantity we are talking about? We are talking about force. So we can take F as 100 Newton. Okay, then the length is nothing but the displacement. See, object is here and it has moved 5 meter. Okay, so that is nothing but the displacement. Displacement is equal to 5 meter. Then we have to find the work done. First we will find the work done. Okay, what is the work done formula? Work done formula is F into S. Okay, so what is F? That is 100 Newton into S, that is 5. Totally it is 500 joules. Okay, unit of work done is also joules. Second one, we have to calculate the potential energy, correct? What is the formula for potential energy? Mass into gravity into height. So in this question, mass is not given, gravity value is not given, height is also not given. If you assume the displacement, okay, if the displacement has height, then it is completely wrong. Okay, you have to take this height. So this is the height we want. So here h is equal to 3 meter. Height is different and displacement is different. In the previous question also, whenever we are talking about the ladder and the person who is on the ground and reaches the 10 meter height, we did not take the height as the length of a ladder. We took the height from the ground surface as 10 meter. So here in this question also, you should not take this displacement as height. Height is this one. Okay, whenever we are talking about potential energy, then we have to talk about this one. Whenever we are talking about displacement, we have to take this one. Okay, now m into g, we don't have the value, correct? But what is m into g? If we multiply m and g, then what we will get? We will get force, that is directly given. So combining these two, we can write it as F into h, correct? Now F is 100. Height, we should not take 5 meter, we have to take this perpendicular height, that is 3. This 3 we have to take it only for potential difference, not for work done. Okay, now 100 into 3, that is 300 joules. Now we'll talk about the third question. Account for the difference in the work done by the force and the increase in potential energy of the block. So what is the difference between work done and the potential difference, and what is the reason for it? They are asking for a account, right? Account is nothing but the reason for this different. In the previous question and all, we used to take work done is equal to the potential energy, correct? But in this question, the displacement and height are different, that is why we are getting different answer. If displacement and height are same, then we will get the same answer. Now why there is a difference in work done and potential energy? First we will find the difference. So difference is equal to 500 minus 300, that is 200 joules, correct? They are asking for the reason. The reason is the loss of energy due to friction. The loss of energy due to friction while moving the block on the slope. That's it. Question number 10. Find the kinetic energy of a body of mass 1 kg moving with the uniform velocity of 10 meter per second. First, as usual, we are going to write the given data. Question number 10, what are the given data? Mass is equal to 1 kg, velocity is equal to 10 meter per second. We have to find the value of k. Very simple. What is the formula for kinetic energy? Kinetic energy is equal to half mv square. Substitute the values and we will get the answer directly. What is the value of mass? 1 kg into what is the value of v, that is 10. We have v square, so 10 square. So half into 1 into 10 into 10. 2 ones are 2, 5s are 5 into 10, that is 50 joules. So whenever you calculate any value in any numerical, try to write the resultant value, okay, in the form of sentence. So whenever we see that value directly, we won't see all these things, okay. First, the important thing is formula, then substitution. If the substitution, listen carefully, very important thing. Once you write the formula and if you substitute the value correctly, we don't see any of these things. Okay, if this is correct and this is correct and the final answer is correct, we don't see any of these things. Okay, we will give you full marks. This is what we used to do while correcting your papers in the board exam. So don't make any errors in formula, substitution and final answer along with the unit. So if you don't write unit, assume there are 10 numericals in the board exam. If you miss 10 units, you will definitely lose 10 marks. Okay, so make sure you are writing the unit and the value properly. Question number 11. If the speed of a car is halved, how does the kinetic energy change? Very simple question. Listen. So now assume the speed is equal to v. Okay, once the speed is reduced to its half, okay, speed is reduced to its half, what is the change in kinetic energy? Okay, in both the cases, with a normal speed and the speed which is reduced to half, in both the cases mass of the car remains same, so mass is not going to affect kinetic energy. What is the kinetic energy formula? K is equal to half mv square. Now we have to cancel the constant quantities. Now here in this formula, so half is not going to change, that is a constant, and m, mass of the car, is also a constant. Why? Because if speed increases or decreases, mass of the car remains same, so that is why we are cancelling it. Now the remaining thing is v square. So here we have to take it as v by 2. Why? Because in the question they have mentioned the speed has been reduced to half. If they have told speed has been doubled, then instead of dividing by 2, you have to multiply it by 2. Okay, so here the speed has been reduced to half, so instead of v, I'll write v by 2 whole square. Okay, it is not v square by 2, it is v by 2 whole square. Then this will be v square by 4, correct? So v square into v square. So 2 square is nothing but 4. So this value will tell us the final answer. So this will tell us, see, the value is in denominator, correct? So the kinetic energy will reduce to 4 times to the original value, or else we can tell it as it has been reduced to 1/4 of its original value. So one thing you have to keep in mind. Okay, based on this one, many questions you can expect. First, if mass is doubled, what happens to kinetic energy? Kinetic energy will also get doubles. Kinetic energy will also get doubles. If the mass is tripled, then we can write mass as 3m. If mass is increased to 3 times, then kinetic energy will also increase to 3 times. But this is not the same case when it comes to velocity. Here again, if mass is reduced to half of its original value, kinetic energy will also reduce to its half of its original value. But when it comes to velocity, you have to be very careful. If velocity is increased 2 times, kinetic energy will increase 4 times. Why? Because velocity square we have. If the velocity is increased 3 times to the original value, then kinetic energy will increase 9 times to the original value. In the same way, if the velocity speed is reduced to its half value, kinetic energy will reduce to its 1/4 value. That means kinetic energy will reduce to 1/4 of its original value. If the velocity is reduced to 1/3 of its original value, then kinetic energy will reduce to 1/9 of its original value. So if the velocity increases 2 times, kinetic energy increases 4 times. If the velocity decreases by 2 times, kinetic energy decreases by 4 times. So if you know this pattern, any question if they form using this kinetic energy, you will be able to answer it. Question number 12. Calculate the decrease in kinetic energy of a moving body if its velocity reduces to half of its initial value. This is exactly like the previous question. In the previous question, they were looking only for the answer. In this question, we have to show how we got to that answer. First we will write the given data. Question number 12. Initially, we have for k1, assume k1 is initial velocity. Initial velocity, the formula was of mv square, correct? When the velocity reduces to its half, then we will get final velocity, that is nothing but half mv square. Here you should not use v square by 2, you should use v by 2 whole square. The velocity has been reduced to its half. Now we will find the answer. So total kinetic energy will be equal to initial kinetic energy minus final kinetic energy. Why I am not writing final kinetic energy at the beginning? Because final kinetic energy has less value. That is why I am writing this one here. Initial kinetic energy has more value. If I put kf here and kinetic energy, initial kinetic energy that side, then we will get the negative value. So whenever you are doing like this subtraction, you have to put the maximum value first. Then initial kinetic energy formula is half mv square minus here half mv by 2 whole square, correct? Now here what is common? Half and m is common. We will take the common. Then here v square minus v square by 4, correct? See, I have written v square as it is. V by 2 whole square is nothing but v square by 4, correct? You have to multiply this square to v and as well as 2. That is why we got v square by 4. So 1 by 2 m v square. So once you take the LCM, this becomes 4v square minus v square by 4. This is nothing but half m 3v square by 4, correct? Now we will write this 3 by 4 at the beginning. We have remained with half mv square, correct? See, I have taken this 3 by 4 outside. Why I have taken, I will tell you. Half mv square is nothing but kinetic energy, correct? Kinetic energy. So This is the final one, correct? So final kinetic energy will be equal to 3 by 4th time of initial kinetic energy. So this is how we will calculate when it comes to equations. Question number 13. Two bodies of equal masses are moving with uniform velocities v and 2v. Find the ratio in their kinetic energies. Very simple question. Listen, first we will write the given data. So here they are telling masses are equal, correct? Assume m1 m2 is equal to m only. Mass of body 1 and mass of body 2, they are equal. Then v1 is equal to v, v2 is equal to 2v. Okay, what is v1? v1 is nothing but velocity of the object 1 or a moving object 1, and v2 is nothing but velocity of the moving object 2. Then we have to find the ratios of their kinetic energy. Very simple. First we will find the answer for first object, that is first moving object. Kinetic energy 1 is equal to half m v1 square, correct? v1 square. Then kinetic energy of the second body is half m v2 square, correct? So here now we will substitute v1 and v2. So v1 is nothing but v, so this will become half mv square, and here v2 we have taken it as 2v, that is given in the question, half m 2v whole square. This is the important thing, okay? 2v whole square. If you use, okay, v square into 2, that is wrong. V square into 2, you will get a different answer. 2v square, you will get a different answer. Now we have to take the ratios. So this again we will simplify. So 2v square is nothing but 4v square, correct? m 4v square. See, this is important. This square is for both 2 and v, that is why it has become 4v square. Now we will substitute in the ratio form. K1 by K2 is equal to, first we will substitute K1 value. What is that? Half m v square. What is K2 value? Half m 4v square. Half will get cancelled, m and m will get cancelled. So here we have v square and 4v square. V square and v square will get cancelled. We are remained with 1 by 4. So 1 by 4 we can write it in the ratio form as 1:4. This is the ratio we are looking for. Listen, very simple. You just have to understand the concept, what are the given things, substitute the values, and simplification. This simplification is very much important. If you write 2v square, finally you will get answer as 1:2. That is completely wrong. You should take it as 2v whole square. You got my point? 2v square is different, 2v whole square is different. Very important thing. Question number 14. A car is running at a speed of 15 km per hour while another similar car is moving at a speed of 45 km per hour. Find the ratio of their kinetic energy. This is very similar to the previous question. What is the only difference between previous question and this question? In that question, v value, the velocity value or the speed value was not specified. In this question, it has been specified. The same thing we are going to apply. Instead of writing v, we are going to write the values. We will get the answer directly. Okay. Question number 14. Here we are talking about two cars, okay, and he has mentioned two similar cars, right? So mass 1 and mass 2, mass of the first car and mass of the second car will be equal to mass, because he has mentioned it is a similar car. Then v1 is equal to 15 km per hour, okay. Then v2 is equal to 45 km per hour. See, keep one thing in mind. What is the unit of velocity? Meter per second. Or what is the unit of speed? That is meter per second. In both the cases it has mentioned in kilometer per hour, but whenever we are finding the ratio, if it is in meter per second or kilometer per hour, if it is in SI unit or in any other unit, it doesn't matter. If you convert into meter per second, okay, if you convert into the SI unit and calculate the answer, we'll get the same answer. Without converting also, we can get the same answer. This method we have to use only when we are calculating the ratios. If you are calculating the kinetic energy, then you have to convert into the SI unit. What is the SI unit of speed? Meter per second. Here it is in kilometer per hour. If you are just calculating kinetic energy, you have to convert into SI unit. Here we are finding the ratio, no need to convert it. Okay, now kinetic energy 1, the formula is equal to half m v1 square, and that is nothing but half m. What is v1? v1 is nothing but 15, so that is nothing but 15 square. Then k2 is equal to half m v2 square, that will be half m. What is v2 value? That is nothing but 45 kilometer, right? So 45 square. Okay, now we have to calculate the ratio. Now we'll substitute the values. K1 by K2, that is nothing but half m, the final value, that is 15 square, divided by K2 value half m 45 square, half m 45 square. Half will get cancels, m and m will get cancels. We are remained with 15 square. I can write 15 square as 15 into 15, 45 square as 45 into 45, correct? 15 ones are 15 threes are, 15 ones are 15 threes are. So 1 into 1, that is 1, 3 into 3, that is 9. So whenever you are converting a fraction into a ratio form, make sure it is in simplified form. It should not be cancelled again. See, 1 and 9 cannot be divisible by any number. In this case, it has to be. Okay, if you have 3 by 9, if you write that as 3:9, that is completely wrong. So whenever you are converting the fraction into a ratio form, it has to be in simplified. It should not be divisible again. So now it is 1:9. This is the answer we are looking for. See, compare this question to previous question. There was no numbers. Here we have number. That's it. The logic is completely same. Question number 15. A ball of mass 0.5 kg slow downs from a speed of 5 meter per second to that of 3 meter per second. Calculate the change in kinetic energy of the ball. Very simple question. Here again you don't have to use the formula 2 times. We have a simplified formula. Okay, this is question number 15. First you understand the concept. Assume there is a ball, okay, of mass 0.5 kg, that is mentioned in the question. Now the present it is moving in 5 meter per second, and after few seconds it has slowed down its speed to 3 meter per second and the mass is same. This is important. Okay, initial value was 5, now it is 3 meter per second. We have to calculate the change in kinetic energy. See, mass is same but the speed is different. There will be a change in kinetic energy that we have to find. See, first we will find the kinetic energy of this case, then this case, we'll subtract, we'll get the answer, correct? Instead of doing that, we have the simplified formula from the textbook only. I will teach you. Listen. Kinetic energy, in both the cases, mass and that half from the formula, 1/2 from the formula will remain same, correct? Half and mass. Okay, these two are from the formula. These, in both the cases, these two are not going to change. Now we have two different speeds, correct? They are asking for change in kinetic energy. Whether it is change in kinetic energy or change in potential energy, we have to subtract the two different values. Okay, now here what is the first one? Velocity 1, v1 square minus v2 square, correct? Why we have to take this as first and this not first? Because this has maximum value. Just to avoid the negative value, we are using this one. 5 meter per second, that is nothing but the v1, velocity 1, speed 1 value. So v1 square minus v2 square. If you use v1 minus v2 whole square, that is completely wrong. See, v1 minus v2 whole square, this is completely wrong. Okay, don't use that. Now we'll use this one. half. What is the value of mass? 0.5. See, here we are not calculating any ratios, correct? So make sure all the values are in their SI unit. What is the SI unit of mass? Kg. What is the SI unit of speed? That is meter per second. Both are correct, don't need to convert into anything. If the speed is in kilometer per hour, you have to convert into meter per second. If you don't know how to do that, that is what we have taught in physics basics. That video will be available in the description box. That will cover the complete basics required for the physics. Now, what is V1 square value? That is 5 square minus V2 square value is 3 square. Okay, so half into 0.5 into what is 5 square? That is 25 minus 3 square, that is 9. So half into 0.5 into 16, correct? 2 ones are 2 8s are. So whenever you multiply any number with 0.5, whatever the value we have, that will become half of it. So answer will be 4 joules. Okay, if you multiply any number by 0.5, it will become half. If you divide any number by 0.5, it will become double. I'll give you an example. 4 divided by 0.5, that will become 8. Okay, you can calculate it and try. Okay, now you understood the method. This is how we have to calculate the answers. Question number 16. A cannonball of mass 500 grams is fired with a speed of 15 meter per second. Find its kinetic energy and its momentum. Very simple question. We have to just apply the formula, substitute the values and get the answer. That's it. Okay, we will write the given data. Mass is equal to 500 grams. Do you think this is the SI unit of mass? No, right? Before substituting the values, we have to convert that into its SI unit. What is the SI unit of mass? Kg. How do you convert from gram from kg? 500 grams is nothing but 0.5 kg. So gram to kg divisible by 1000. Next, velocity is given. That is 15 meter per second. Velocity, speed, both are almost same, not equal, almost same. When it comes to values, if you take v as speed, that is also fine. Okay, do you think this is the SI unit of speed or velocity? Yes, meter per second is the SI unit of velocity. If you don't know how to convert from kilometer per hour to meter per second, you have to learn. That will be in the description box. Okay, called physics basics. Now if it is in kilometer per hour, you have to convert into meter per second, then you have to substitute, or else you will get the answer, but the answer will be completely wrong. If the answer is wrong and the unit is correct, you will not get any marks. Okay, so before substituting, it has to be in SI unit. Okay, next we have to find kinetic energy and also momentum. Okay, what is the formula for kinetic energy? K is equal to half mv square, correct? Substitute the values. Half I'll write as it is. Mass, it is nothing but 0.5. Then v, what is v? That is 15. 15 square, I can write it as 15 into 15, correct? So if you calculate all these things, we will get it as 56.25. What is the SI unit of kinetic energy? That is nothing but joules. Okay, second one, this was the first one, right? Second one, we have to find the momentum. See, once you find the answer, write therefore symbol, write it in the form of sentence. If you do like that, whenever I am correcting your paper, if I see that, I'll get a good impression, so that next time onwards, next question onwards, I will not check that much thoroughly. Okay, now we'll find momentum. Okay, what is the momentum formula? Mass into velocity. Okay, what is mass? That is 0.5 into velocity, that is 15. See, I told you earlier, whenever you are multiplying any number with 0.5, that becomes half of it, correct? So half of 15 is 7.5. What is the unit of this one, momentum? What formula we are using? Mass into velocity. What is the unit of mass? Kg. What is the unit of velocity? Meter per second. Only for this one we are doing like this, because it doesn't have any significant unit. Question number 17. A body of mass 10 kg is moving with a velocity 20 meter per second. If the mass of the body is doubled and velocity is halved, find its initial kinetic energy and final kinetic energy. Very simple question. If you know the concept, see formula, concept, then we'll get the answer directly. Okay, this is question number 17. Okay, first we'll write what are the given data. Mass of the object is equal to 10 kg. Then velocity is given as 20 meter per second. Okay. Now after giving this data, he is telling if the mass is doubled. Okay, now again he is talking about a different mass and different velocity, right? So we'll take this as m1 and this as v1. Next, m2, if the mass is doubled. Okay, what is the initial mass? That is 10 kg. Now if we double it, that becomes 20 kg. Then if the velocity is half, correct? Then what is the half of 20? That is 10. So v2 will become 10 meter per second. See, we have one mass, one velocity, we can find kinetic energy. We have mass and velocity, different mass and different velocity, again we are going to get kinetic energy. That's it. That is what they are asking. See, if you write the given data, then substituting the values and getting the answer in their SI unit. That's it. Okay, first kinetic energy 1. Okay, K1, what is the formula? Half m v square. Half, I'll write it as it is. What is mass? 10 kg into what is v? V is 20, right? So v square can be written as 20 into 20. 2 1s are 2 5s are 20 into 20, that is 400. 400 into 5, that is 2000. So K1 value will be 2000 joules. Next, K2. Again I'll apply the same formula. Here values are different, that's it. 1 by 2 into mass is doubled, that is 20, into V, that is half, that is 10 into 10. 2 1s are 2 10s are. So 10 into 10 into 10, that is 1000 joules. That's it. Question number 18. A truck weighing 1000 kg changes its speed from 36 km per hour to 72 km per hour in 2 minutes. Calculate the work done by the engine and its power. We can take G as 10 meter per second. Okay, listen. Here first we will write the given data, then we will discuss what to find. Okay, the weighing, the truck weighs 1000 kgf. Kgf and kg, you know, both are same. So we can take mass as 1000 kg or kgf. Anything is fine. Okay, because both are same. Next, initially it was traveling at 36 km per hour, then accelerated to 72 km per hour. So we have two speeds. We can write that as V1 36 km per hour, then V2 will be 72 km per hour. Okay, so these are the given data and time is also given. Time is given as 2 minutes. Okay, we need to find work done and power. Okay, here you will definitely get a doubts. Okay, listen, first thing is mass is fine, correct. Velocity, in both the velocities it is given in kilometer per hour. Do you think kilometer per hour is a unit of velocity or speed? No, it has to be in meter per second, right? First you need to convert into meter per second, then we'll talk about these two. Okay, see, from kilometer per hour to meter per second, you have to multiply it with 5 by 18. So 36 into 5 by 18. Why this 5 by 18? This is a simple logic that you have learnt in school also. If you don't know, you can follow this method in our physics basics video, which will be available in the description box. Okay, now 18 ones are 18 twos are 5 twos are 10 meter per second. Okay, now do you think, do we have to convert this one also? No. If you think logically, we don't have to convert this, we can write the answer directly. Very simple, listen. 36, we got 10 meter per second. 72 is double of this 36. Then meter per second will answer also will be double, right? That will be 20 meter per second. For your satisfaction, I will write it on the board, don't worry. So 72 into 5 by 18. Why 5 by 18? To convert from kilometer per hour to meter per second, it is 5 by 18. If you want to convert from meter per second to kilometer per hour, it is 18 by 5. Why? I told you, right? It is in the physics basics video that is available in the description box. Okay. So here 18 ones are 18 fours are 5 fours are 20 meter per second. Okay. Now we got all the units in their proper SI units, right? No, we have to convert time also. What is the SI unit of time? That is in seconds, correct? Minute should be in seconds. For 1 minute it is 60 seconds. For 2 minutes it is 120 seconds. Now all the values in their SI unit. Now we have to worry about this work done and power. What is the formula for work done? Force into displacement, correct? Here to find force, okay, we require two things, mass and acceleration due to gravity. Mass is given, gravity value they have given it as 10. Where is the displacement? That is not given here. Okay, we don't have to calculate all those things. See, initially in the concept video I told you, whenever we are talking about kinetic energy, that is nothing but work done. Okay, work done is equal to kinetic energy. If we find the value for kinetic energy, that will be equal to work done. This logic, if you don't know, that means you don't know the concept. That is what I have taught in the concept video. All those concept video, then we have solved all the theory questions which is there in your textbook. Now we are solving all the numericals from the textbook. All these things will be available in the description box. First you need to understand the concept video, then if you go for theory, and then if you come for the numericals, you will understand everything. So work done is nothing but kinetic energy. If we know kinetic energy, that is nothing but work done. Once we find the work done, we can easily find power. I'll teach you the formula, don't worry. Okay, I told you work done is nothing but the kinetic energy. So work done is equal to half mv square. In the bracket you can write, okay, since this is the symbol for since work done is equal to kinetic energy, you can write it in the bracket. Before substituting the values, we need to understand that we have two velocities, okay, two velocities, and when it comes to kinetic energy, v2 minus v1 we have to take. Why v2 minus v1 inside the bracket? These two will remain same. Here v2 square minus v1 square we have to use, correct? Why v2 first? Because this has a maximum value. If we take this as first value, then we will get the answer as negative, correct? So to avoid the negative value, we will put the bigger value first. Okay, this will go like this, half, I'll write it as it is. Mass is nothing but 1000. Next bracket. So here v2 square minus v1 square. Okay, this is very much important. If you just take v2 minus v1, that is completely wrong. If you take v2 minus v1 whole square, that is also completely wrong. It should be v2 square minus v1 square. You know why we are taking v2 first, right? Okay, now we will substitute the values. Half into 1000 into 20 square minus 10 square. So half into 1000 into, see, 20 square is 400, 10 square is 100. So 400 minus 100, that will be 300. So 2 ones are 2, 500s are 5 3s are 15. Okay, don't worry about this one. 5 3s are 15. How many zeros are there? 1 2 3 4. 1 2 3 4 joules. So whether it is work done or kinetic energy or potential energy, if something ends with energy, the unit will be joules only. Now we got to know the value of work done. We'll find the value of power. Okay, what is the formula for power? That is nothing but work done by time taken. And one more thing, listen. In the textbook, whenever you are finding the answer, sometimes it will be in decimal. Like you can keep this one as 0.15 into 10 power 6 joules, that is also fine. If you keep it like this, this is also fine, or else 1.5 into 10 power 5 joules, anything is fine. So don't worry about the decimal values. If you keep it like this, you will get full marks. Now we'll substitute the answers here. Okay, 1 5 1 2 3 4 zeros divided by time 120. For 1 0 1 0 get cancels. When we divide 15,000 by 12, we will get 1250 as an answer. What is the unit of power, that is value. That's it. So if you get these kind of questions, you don't have to worry about work done. Okay, kinetic energy is nothing but work done. Once we find work done, it is easy to find power. Question number 19. A body of mass 60 kg has a momentum 3000 kg meter per second. Calculate the kinetic energy and the speed of the body. First we will write the given data. Question number 19. So they have given mass as 60 kg and they have given momentum, that is 3000 kg meter per second. Then we have to calculate kinetic energy and speed of the body, that is nothing but v. Okay, now they have given mass and momentum and they are asking the answer for kinetic energy. How we can find this? This is what we have learnt in concept video. What is the relationship between kinetic energy and momentum? So the relation will be k is equal to p square by 2m. This is the relation between kinetic energy and momentum. If we know this one, then substituting the values and getting the answers. That's it. Okay, we'll substitute the values. Okay, p, it is nothing but momentum, that is 3000 into 3000 divided by 2 into what is the mass, that is 60. Correct. For 0 get cancelled. 2 ones are, this is 1500. Finally, when we solve all these things, we will get 75,000 joules. That's it. See how easy it is. Once we substitute the values, we will calculate the answer and get it. That's it. Okay, now we'll find velocity. Okay, we found the kinetic energy. Second one, we have to find the velocity. Okay, now how is velocity related to kinetic energy and momentum? How is velocity related to kinetic energy and momentum? Kinetic energy is equal to half mv square. Correct. Half mv square. Okay, then what is the formula for momentum? Mass into velocity. See here, when it comes to momentum, just mass into velocity. In kinetic energy, half mv square, which is complicated kinetic energy. So we don't have to use kinetic energy formula. So we'll use momentum formula itself. Okay, what is momentum formula? Momentum is equal to mass into velocity. So mass, that is 60. Velocity we have to find. Okay, momentum they have given as 3000. So v is equal to 3000 divided by 60. Correct. So if we want to find the value of v, you send this 60 this side, this will become 3000 by 60. 300 divided by 6, that will be 50 meter per second. That's it. See, units are very much important. If the units are wrong, definitely you will lose 1 mark every time. In every question, if the units are wrong, every time they will deduct 1 mark everywhere. So be careful while writing the units. Question number 20. How much work is needed to be done on a ball of mass 50 grams to give it a momentum of 5 kg meter per second? First we will write the given data, then we will discuss about the question. Okay, here question number 20. What are the things given? Mass, that is 50 grams, then momentum is given. What is the symbol for momentum? Slanted p, right? Momentum, that is 5 kg meter per second. We need to find the work done. Correct. See, if you know the concept very well, then it is easy to answer. What do you mean by work done when it comes to momentum or kinetic energy? Work done is nothing but kinetic energy. If we have momentum and mass, we can find kinetic energy. Kinetic energy is nothing but the work done. So what is the relationship between momentum and kinetic energy? That is what we have used in previous sum also. Correct. K is equal to momentum square by 2m. This is the relationship between momentum and kinetic energy. Using this one, we will find kinetic energy. Kinetic energy is nothing but the work done. That's it. So instead of using K here, we can use W also. Anything is fine. So momentum square. What is momentum? 5 into 5. Why? Because we have momentum square. Okay. Before substituting the mass value, we have to see whether it is in SI unit or not. Correct. It is in gram. We have to convert into kg, then only we have to substitute here. If you convert 50 gram to kg, that is nothing but 50 divided by 1000. We will get it as 0.05 kg. Correct. Now 2 we will write it as it is. What is mass? Mass is nothing but 0.05. Okay, now if you simplify, you can simplify it any way. Okay, you will get the same answer. So 5 into 5 divided by 100 to get rid of this decimal form. So 2 into 5, correct? 5 will get cancelled. 2 ones are 2, 50s are. See, this is my method of calculating. You can use any method. Next, 5 5s are 25, 1 0. So we are calculating work done. Work done unit is joules. That's it. Question number 21. How much energy is gained by a box of mass 20 kg when a man carrying the box waits for 5 minutes for a bus? This is the first sub question. Second sub question, runs carrying the box with the speed of 3 meters per second to catch the bus. Then third sub question, raises the box by 0.5 meter in order to place it inside the bus. Take g value as 10 meters per second square. Okay, first we will write the given data one by one. Question number 21. Okay, mass of the box is 20 kg. Okay, now we'll start with our first sub question. Carrying the box, wait for 5 minutes for a bus. Okay, here you need to understand, whenever we are talking about energy, that is nothing but we are talking about work done. Okay, if we are talking about energy, truly energy, then the time value will be given in hours. Okay, energy is equal to power into time. That is different. Here in this question, there is no time value given, so definitely we are talking about work done only. So in first case we have to find the work done. Okay, listen. If you are carrying a box or anything, if you are not moving, then work done will be 0. Why? What is the formula for work done? Work done is equal to force into displacement. To carry that luggage or a box, we have to apply some force. So force is definitely there. What about displacement? If you are not moving, do you think there will be a displacement? If there is no movement, displacement will be 0. If displacement is 0, work done will also be 0. For the first case, work done will be 0. Okay, you can write it in the bracket, since there is no displacement. If there is no displacement, no work will be done. You can write it as no displacement. Okay, this is understood. If you write this, you will definitely get full marks. Okay, second sub question, runs carrying the box with a speed of 3 meters per second to catch the bus. Okay, here they have given velocity, that is 3 meters per second. Okay, now we have to calculate some energy, correct? Which energy is that? We have mass, and for second sub question we have velocity also. With the mass and velocity, what kind of energy we can calculate? Kinetic energy. So for the second sub question we have to calculate kinetic energy, formula half mv square. Okay, listen. Using mass and velocity we can also find momentum, but momentum is not a energy. Kinetic energy, see in the name itself we have the word energy, so that's why with mass and velocity we have to find kinetic energy. This is the formula, half, what is mass, that is 20 kg, into velocity v square, that is nothing but 3 into 3, 2 ones are 2 tens are 3 into 3, 9, 9 into 10, that is 90 joules. So kinetic energy is equal to 90 joules. Third one, raises the box by 0.5 meter in order to place it inside the bus. So we can take g as 10 meters per second. Here in this third sub question, they have given height is equal to 0.5 meter and g is equal to 10. Don't worry about the unit when it comes to gravity. Now we have already as mass. Okay, now whenever we are raising something, okay, whenever we are raising something, what is getting increased? Potential energy. So in this question, okay, mass, gravity and height. What is the formula for potential energy? mgh. mgh. We have to find potential energy. So this is how, based on the given data, we need to understand what we have to find. Okay, so potential energy symbol will be U, formula will be mgh. What is m? That is 20, g is 10, h will be 0.5. Okay, 20 into 10 into 0.5, that will be 100 joules. That's it. So first you need to understand what are the given data. According to that we have to apply the formula and get the answers with the proper unit. Question number 22. A bullet of mass 50 gram is moving with a velocity of 500 meter per second. It penetrates 10 centimeter into a still target and comes to rest. Calculate the kinetic energy and average retarded force. Okay, first we will write the given data. We will solve one by one. We will understand everything easily, and this is a very simple question. Okay, what are the given data? Mass of a bullet, that is 50 gram. See, this is not in SI unit. We have to convert into SI unit before substituting the values. So 50 divided by 1000, we will get the answer in terms of kg. That will be 0.05 kg. Okay, next. Velocity is given, that is 500 meter per second. So meter per second is the SI unit of velocity. No need to convert into any SI units. Okay, next. It penetrates 10 centimeter. So some displacement is given, correct? Displacement or distance is given, that is 10 centimeter. Do you think centimeter is the SI unit of displacement? Okay, no, it is meter. So how do you convert centimeter to meter? Divided by 100. So 10 divided by 100 will be 0.1 meter. Next. Okay, these are the given data. First we will find kinetic energy. First we have to find kinetic energy. What is the kinetic energy formula? Half mv square, correct? Half, I'll write it as it is. M, it is nothing but 0.05. Next we have to apply velocity. Velocity is 500 square, that is 500 into 500. Okay, 2 1s are, this one 2 50s are. So now 0.05 into 250 into 500. Once we calculate all these things, we will get the answer as 6250 joules. Okay, first question answer is done. Now we will talk about the second one, where you will get little confused. Okay, the average retarded force offered by the target. Okay, listen, first you need to understand the question. Okay, average retarded force. Okay, what do you mean by retardation? Slowing down. So while slowing down, what is the force they are asking offered by the target? Whom do you think the target here? It is the object, still object, which is getting the bullet inside it. Okay, so that is the target. Okay, now we have to understand in this question what we have to find? Retarded force. That is nothing but force only. We have to find force. Okay, what do we have? We have kinetic energy. Okay, mass, velocity, displacement and kinetic energy. Okay, by using which formula we can find the value of force? Okay, listen, we already know that kinetic energy is nothing but work done, correct? Kinetic energy is nothing but work done. We have work done. Okay, we have displacement, we have to find force. What is the work done formula? W is equal to F into S. So work done is equal to F into S. We have the work done value, that is nothing but kinetic energy value. So, and we have also displacement. It is easy to find force. What is the value for kinetic energy? 6250 is equal to F into, what is the S value? That is 0.1. Okay, if you want to find value of F, you move this one this side, that becomes 6250 by 0.1 is equal to F. That is nothing but F is equal to 62500. What we are finding? Force. What is the unit of force? Newton. That's it. See, this is how you merge two concepts to get the answer. Our last question. A spring is kept compressed by a small trolley of mass 0.5 kg lying on a smooth horizontal surface as shown in the diagram. When the trolley is released, it is found to move at a speed of 2 meters per second. What potential energy did the spring possess when compressed? Okay, listen, we need to understand few things here. See, there is a spring and there is a trolley. If the trolley is not there, this will be the size of the spring. Assume this is the size of the spring. When the trolley is moved towards the spring will get compressed. Now the question is, once this trolley is moved away, what is the potential energy in the spring? This is what we have to calculate. Okay, listen, first we will write the given data. Mass is equal to 0.5 kg. Then the velocity is given, that is nothing but 2 meter per second. We have to find the potential energy. Okay. When the trolley is used to compress the spring, some energy will be stored in the form of potential energy in this spring, right? Now, when this trolley moves away, this potential energy will be converted into kinetic energy. The complete potential energy will be converted into kinetic energy. So, in this question, if we find the answer for kinetic energy, that is nothing but potential energy, because whatever the potential energy was there, okay, when the trolley was compressed the spring, okay, then that potential energy is converted into kinetic energy. So if you find kinetic energy, that is nothing but the potential energy. Kinetic energy is equal to half mv square. Half, I'll write it as it is. What is the mass? 0.5 kg, and before substituting the values, we have to know that everything is in SI unit. Mass is in kg, velocity is in meter per second, so no need to worry about units. Mass, that is 0.5 into velocity, that is 2 square, that is nothing but 2 into 2. 2 and 2 get cancelled. So whenever you multiply any number by 0.5, that becomes half of it. What is the half of 2? That is 1 joule. Finally, we can conclude like, when the spring is released, potential energy is converted into kinetic energy. Therefore, you have to write that sentence. Therefore, kinetic energy is equal to potential energy, that is nothing but 1 joule. Okay, you have, before this statement, you have to write, when the spring is released, potential energy will be converted into kinetic energy. Therefore, kinetic energy is equal to potential energy, that is nothing but 1 joule. See how many questions we have solved. In every question we have learned something new, correct? So that is why I'll tell every student to solve each and every numerical, so that in a board exam you may get the same question or some modification will be there in the question. You will definitely get the answer easily if you know the logic. So if you have solved all the numericals, then you have all the knowledge in your brain. So if you keep on practicing like this for all the chapters, then you will be 99% thorough for the board exam. What is that 1% remaining? That is for application oriented question. They will create some question, you apply there properly and get the answer easily. Thank you.